Hello everyone, in this part 8 of trigonometric functions, we will do the solution of questions with explanation. So let's start with question number 1. In question number 1, we have cot x is equals to 3 by 4, where x lies in third quadrant, and we have to find out the values of other 5 trigonometric functions. So to do this question, there are different methods. We will use this method only as we know that according to the basis of identity, cosec square theta is equals to 1 plus cot square theta. So cosec square theta is equals to 1 plus, it means cosec square x is equals to 1 plus 3 by 4 whole square. It means this become 25 by 16. It means this become 5 by 4 whole square. It means cosec x is equals to plus minus 5 by 4. Here you will say cosec x is equals to, because it is in third quadrant, therefore it will come minus pi by 4. And here you will write down because x lies in third quadrant. So we have cosec x is equals to minus pi by 4. Now simply sin x is equals to 1 upon cosec x. It implies that this is equals to minus 4 by 5. Now tan x is equals to what we have 1 upon cot x. It implies that this is equals to 4 by 3. Another thing we have now cosec and this. We have already sin is here. So you can do on the basis of this thing cot x is equals to cos x upon sin x. Now cot x is equals to 3 by 4. Sin x is equals to what is this thing? Minus 4 by 5. It means this is equals to cos x. It implies that cos x is equals to minus 3 by 5. And automatically it is coming negative because it lies in third quadrant. Now sec x is equals to 1 upon cos x. It means this is equals to minus 5 by 3. And this is the answer. So this is the way to do this type of questions. Now in question number 2, we have to prove that sin x plus y upon sin x minus y is equals to tan x plus tan y upon tan x minus tan y. So first of all we will take left hand side. In left hand side, sin x plus y upon sin x minus y. Now we will open the identity here. It means sin a plus b, sin a cos b plus cos a sin b. It means this become cos x sin y. And this is now sin a cos b. It means cos y minus cos a sin b. It means this is sin y. Now because we want result in tan, so what we will do, we will take throughout cos x cos y common. Once we will take cos x cos y common, so here cos x is not there. It means sin x upon cos x is equals to tan x, and this is plus tan y upon, here also take cos x common, cos x and cos y common. So here this become tan x minus tan y. So this is the right hand side, because we are getting here tan x plus tan y upon what is this, tan x minus tan y, which is equals to right hand side. So this is the answer, and using this trigonometric formulas we can prove anything according to the questions. Now let's start with this question number 3. Now in this question number 3, we have to prove that tan 70 is equals to 2 tan 50 plus tan 20. Now for solution you will say, because we know that tan 70, what can we write here? This is tan 50 plus 20. Now open this identity. Tan 70 is equals to tan A plus tan B upon 1 minus tan A tan B. It means 1 minus tan 50 and this tan 20. Now cross multiplication, tan 70 minus tan 50 tan 20, and this is tan 70. This is equals to tan 50 and plus tan 20. Now what we are observing? We are observing we want 2 tan 50. So this is tan 70 as it is minus tan 50, and this is 20 70 90. So we will apply the identity here. We can write down 90 minus 70. and this is tan 70, and this is as it is tan 50 plus tan 20. Now tan 90 minus theta is equals to cot theta. So this is tan 70 minus tan 50, and this is cot 70. Tan theta is equals to 1 upon cot theta. It means cot 70. This is tan 50 plus tan 20. Now this is cancel out. This term will go there. It means tan 70 is equals to 2 tan 50 and plus tan 20. This is the answer. Now to do the other question, look at this thing. We have to remember this thing. Note this point. We know very well, if we have A upon B is equals to C upon D, it means by componendo and dividendo. By componendo and dividendo, what is the rule? Rule is this thing: A plus B upon A minus B is equals to C plus D upon C minus D. We have to use this rule in some questions wherever it is required. It is known as componendo and dividendo. It means numerator plus denominator upon numerator minus denominator is equals to numerator plus denominator upon numerator minus denominator. So this rule we have to use to solve some question, and in our solution of question number 4 we have to apply this rule. Look at this thing. In question number 4 we have sine theta sine 2 theta n plus 1 sine 2 theta is equals to n minus 1 sine 2 alpha, and we have to prove this thing. This part, sorry, question we have this thing: tan theta plus alpha is equals to n tan theta minus alpha, n tan alpha minus theta, and to prove we have to this part. What is this? N plus 1 sine 2 theta is equals to n minus 1 sine 2 alpha. Now let's start with this part. Tan theta plus alpha is equals to n tan theta alpha minus theta. Now first of all we will shift this side. Tan theta plus alpha upon tan alpha minus theta is equals to n plus 1, sorry, n upon 1. Now why we are applying componendo and dividendo? Because in result we want n plus 1 and n minus 1. So by componendo and dividendo, what we are observing? We are observing we will get tan theta plus alpha upon, sorry, plus tan alpha minus theta upon tan theta plus alpha minus tan alpha minus theta is equals to n plus 1 upon n minus 1. Now we can easily write down tan theta means 1 up sine theta upon cos theta. So we will write down here sine theta plus alpha upon cos theta plus alpha plus sine theta minus sine alpha minus theta upon cos alpha minus theta, and this is upon sine theta plus alpha upon cos theta plus alpha minus sine alpha minus theta upon cos alpha minus theta is equals to, what this become, n plus 1 upon n minus 1. Now after taking LCM we will get this thing: sine theta plus alpha cos alpha minus theta plus cos theta plus alpha sine alpha minus theta upon, what is this, sine theta plus alpha cos alpha minus theta minus cos theta plus alpha sine alpha minus theta is equals to n plus 1 upon n minus 1. Now sine A cos B plus cos A sine B. It means this is sine A plus B. And here also sine A minus B. It means sine theta plus alpha minus alpha plus theta is equals to n plus 1 upon n minus 1. Now after cross multiplication we will get n minus 1, and this is sine 2 alpha is equals to n plus 1 sine 2 theta. And this is the proof. It implies that n plus 1 sine 2 theta is equals to n minus 1 sine 2 alpha. So this explanation is very important, because on the basis of this thing we can do so many questions. And the technique is this thing: if we want anyhow in proof n plus 1 n minus 1 like that, one term with addition and subtraction, so most probably there we have to apply componendo and dividendo. Now let's start with this question number 5, which is very important question. Now in this question we have this left hand side and we have to prove this right hand side. This is very important question. In this question, first of all, we will divide by 2, and this means 2 sin x, and multiply by here cos x, and here also cos 3x into cos x. Same thing here, 2 sin 3x already here, multiply by cos 3x upon cos 9x into cos 3x, and in the same way 2 sin 9x cos 9x upon cos 27x cos 9x. This is the very important technique. Why we did like this? Because here we will use the identity 2 sin a cos b. It means 2 sin a cos b means sin 2a. It means this becomes sin 2x cos 3x cos x. 2 sin a cos b means sin 2a. In the same way, this becomes sin 6x upon cos 9x cos 3x. In the same way, this becomes sin 18x, and this is cos 27x cos 9x. Now 1 upon 2 sin 2x, we can write down here sin 3x minus x upon cos 3x cos x. In the same way, sin 6x means sin 9x minus 3x upon cos 9x cos 3x. In the same way, here we can write down sin 27 minus, what is this, 27x minus 9x upon cos 27x cos 9x. So this is the way, which is very important part. These steps are very important. Now we will open this identity. What is this become? Sin a minus b, sin a cos b upon, as it is, cos 3x cos x, and what is this, minus cos a sin b. It means this is cos 3x and cos x. So what we are doing here, we are applying the identity here, sin a cos b minus cos a sin b. In the same way, here we will do, but this becomes sin a cos b cos 9x cos 3x minus cos a sin b upon cos 9x cos 3x. In the same way, in this part, sin a cos b cos 9x cos 27x cos 9x minus cos a cos 27x sin 9x upon cos 27x cos 9x. So in this part we applied the identity and separate out. Now what we are observing here, this become tan 3x, and this is minus tan x. This become tan 9x. This become minus tan 3x. This become tan 27x, and this become tan 9x. Tan 9x 9x cancel out. Then tan 3x 3x cancel out. It means this is 1 upon 2 tan 27x minus 10x, and which is the right hand side. So this is the way to do this type of very important questions, in which we require some technique also. So now don't forget to give the answer of this question in comment box. Thanks and God bless you.